25,0 and E 20,10 and D. What is D? 0,20. These are the corner points. The objective function is maximum Z. Max Z is equal to 17.5x plus 7. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today I am going to discuss a few more problems in linear programming. In previous classes we have discussed regarding the solution of a equation by graphical method and the formation of a linear programming problem and finding the solution by graphical method. In this session also I am going to take few more problems, formation of linear programming problems and the solutions. Now let us come to the first kind. First type of problem. What is the first problem? One kind of cake requires 200 grams of flour and 25 grams of fat. Now there are two types of cakes. Let us consider it as A and B. There are two types of cakes, A and B. One kind of cake requires 200 grams of flour and 50 grams of fat. And other kind of cake requires 100 grams of flour and 50 grams of fat. So here one kind, say A requires 200 grams of flour. This is flour and 20 grams of fat. 20 grams of fat. This is fat. Okay. And another kind, second kind, say B requires 100 grams of flour, this is 100 grams of flour and 50 grams of fat. So the fat for second type is 50 grams. Find the maximum number of cakes which can be made from 5 kg of flour and 1 kg of fat. The maximum availability of the resources are here 5 kg of flour and 1 kg of fat, assuming that there is no shortage of the other ingredient used in making the cakes. Now what is the objective function is to maximize. The maximization is the objective function. So using the maximum resource, what is the resource here? 5 kgs of flour and 1 kg of fat. So we have to manufacture the number of cakes, maximum number of cakes. Now what is the objective function here? The objective function is to maximize the number of cakes. Okay. Now let us define the decision variables as the x and y. Okay. Now let us define the decision variables as x and y. X is the number of cake produced of type A and y is the number of cakes produced of type B. X is the number of cake produced of type A and y is the number of cake produced of type B. What is the objective function? The objective function is max, or here let us write the function first. Z is equal to find the maximum number of cakes which can be made. Maximum number of cakes. So here Z is equal to x plus y. Now what is the objective function? The objective function is max Z is equal to maximum of Z is equal to x plus y. Maximum of Z is equal to x plus y. Now subjected to the constraints. Now very simple. So what is the maximum availability of flour? That is 5 kg. So we have 5 kg. That means 5 kg is equal to 5 kg maximum availability is 5000 grams and 1 kg of fat is nothing but 1000 grams. So constraints are first for the type A. For the type A we have 200 x plus 100 grams of fat, that is y. 200 x plus 100 y is less than or equal to 5000. And for the second type, for B, we have 20 x plus 50 y is less than or equal to 1000. This is for the flour as well as for the fat. Okay. These are the constraints. So I will put it in a mathematical form. So one kind of cake requires 200 grams of flour and 25 grams of fat. Another type of cake B requires 100 grams of flour and 50 grams of fat. Now let us define x and y as the decision variables. For the first type of cake, since the objective function is maximized, to maximize the number of cakes which can be formed is a maximization, that is z is equal to x plus y. The objective function is max z is equal to x plus y. Subjected to the constraints, for the first type of cake A, we have for A, so that is 200x plus 100y is less than or equal to 5000. For the second one, we have 25x plus 50y is less than or equal to 1000. These are the constraints. Now subjected to the constraints. Now I will put it in a mathematical form. So therefore the required LPP is max z is equal to, maximum of z is equal to x plus y, subjected to the constraints, 200x plus 100y, 200x plus 100y is less than or equal to 5000, and the second one is 25x plus 50y is less than or equal to 1000. Okay, these are the, and the non-negative restrictions, x is greater than or equal to 0 and y is greater than or equal to 0. Okay, now if you want, you can divide this by 100. If you divide by 100, what you will get, this is 2x plus y is less than or equal to, so this is 2 0 gets cancelled, 50. Let us consider this as equation number 1. Now here if you divide by 25, you will get x plus 2y less than or equal to 1000 divided by 25. So that is equal to, okay. Now let us divide this equation number 2 by 25. If you divide by 25 gets cancelled, x plus 25, 50 by 2 is 2y is less than or equal to 1000 divided by 25 is 40. Let us represent this as equation number 2. Now solving these equations 1 and 2. Now let us convert this inequalities into equalities. Now for the first line, for line 1, what is the line 1? 2x plus y is equal to 50. Now divide by 50, what you will get? 2x by 50 plus y by 50 is equal to 1. This is 25 times cancel. So therefore A, the coordinates of A is 25 comma 0 and B is equal to 0 comma 50. Similarly for the line 2, for second line, what is the line 2? X plus 2y is equal to 40. If you divide by 40, this is x by 40 plus 2y by 40 is equal to 1. This is 20 times gets cancelled. X by 40 plus y by 20 is equal to 1. Therefore, the coordinates of C is equal to 40 comma 0 and D is equal to 0 comma 20. So these are the points. These are the coordinates of A, B, C and D. For the first line is A 25 0, B 0 50, and for the second line, for line 2, second line, the points are C 40 comma 0 and D 0 comma 40. Now let us represent this on a graph sheet. That's it. Okay. Now let me rub this and I will draw the graph here. I'll write down the points first. Therefore, what is A? A is equal to 25 comma A 25 comma 0, B 0 comma 50, C. What is C? C is 40 comma 0 and D is 0 comma 20. Okay, let me rub this. Okay, I'll draw the graph here. Now let us write down the graph for this. X-axis, y-axis, origin 0 comma 0. What is the maximum value? We have 50. So let us take the scale 1 centimeter is equal to 10 units here. So here we have 10, 20, 30, 40, 50, 60, 10, 20, 30, 40, 50 and 60. Now A, what is A? 25 comma 0, X is 25, 10, 10, this is 25, A 25 comma 0. What is B? B 0 comma 50, X is 0, Y is 50, 10, 20, 30, 40, 50. This is B 0 comma 50. Draw a straight line which passes through these 2 points A and B. This is for the line. Okay. What is this line? First line, that is 2x plus y. See, I will draw the line again. Just join these 2 points A and B. This is A and B. This is AB. What is the line? The first line, 2x plus y. 2x plus y is less than or equal to 50. This is the line. Less than means the feasible region is towards the origin. Now for the second, what is C? C is equal to 40 comma 0, X is 40, 10, 20, 30, 40. This is C, 40 comma 0. And what is D? 0 comma 20, 0, 10, 20. This is D, 0 comma 20. Draw the line which passes through these points. So what is this? The curve is x plus 2y is less than or equal to, x plus 2y is less than or equal to 40 means again this will goes in this direction. So therefore this is the feasible region. I'll shade this. This is the feasible region. Now what are the corner points? These are the corner points O, A, D and this point. Let us call it as E. So if you draw carefully, then you are going to get the value of E. Now if you draw the graph carefully, so you can observe that this will cut at this point. That means x is equal to 20, y is equal to 10. Okay, x is equal to 20 and y is equal to 10. So therefore the corner points are O 0 comma 0, then A 25 comma 0 and E 20 comma 10 and D. What is D? 0 comma 20. These are the corner points. See here, O 0 comma 0, A 25 comma 0, E 20 comma 0 and D 0 comma 20. These are the corner points. Now just substitute in the objective function and find for what value you are going to get the maximum. That's it. Okay, hope you followed this. Now I will substitute here. I will rub this and substitute. Now this is the objective function at O 0 comma 0. Z is equal to 0 plus 0 is 0. Next at A, what is A? 25 comma 0. Z is equal to 25 plus 0 is equal to 25. Next at E, what is E? 20 comma 10. Z is equal to 20 plus 10, that is equal to 30. Next at D, what is D? D is 0 comma 20. Z is equal to 0 plus 20, this is equal to 20. Now what is the intention? To get the maximum Z. What is the maximum value here? This is the maximum value. This is the maximum. So the maximum is 30. So therefore the maximum value is 30 at what are the points? 20 comma 10. So here the maximum cakes are 30 at 20 comma 10. The maximum number of cakes are 30 at x is equal to 20 and y is equal to 10. At x is equal to 20 and y is equal to 10, we will get the maximum number of cakes. The number of cakes are 30. That's it. Now let us go to the next problem. A manufacturer produces nuts and bolts. So a manufacturer produces nuts and bolts. It takes 1 hour of work on machine A and 3 hours work on machine B. So there are 2 types of machine A and B, which manufactures nuts and bolts. So to produce a package of nuts, it takes 3 hours on machine A and 1 hour on machine B. So it takes 3 hours to produce the package of nut. It takes 3 hours on machine A and 1 hour on machine B to produce a package of bolts. E earns a profit of rupees 17.50 per package on nuts and rupees 7 per package on bolts. So that means here the profit is again to maximize. The objective function is to maximize how many package of each should be produced each day so as to maximize his profit. If he operates his machine at the most 12 hours a day. This is very important problem. So there are two types of machines, machine A and machine B, which produces bolts and nuts. Now let us consider there are two types of machine A and machine B. Okay, these are the two machines. Now what they produces, nuts and bolts. Okay, now the maximum time available. Now let us define the decision variables as x and y. So A will produces, it takes 1 hour for a machine A to machine A and 3 hours on a machine B to produce 1 hour. So a manufacturer produces nuts and bolts. It takes 1 hour work on machine A and 3 hours on machine B to produce a package of nuts. To produce nut, A will takes 1 hour, B will takes 3 hours. And it takes 3 hours on machine A and 1 hour on machine B. 3 hours on machine A and 1 hour on machine B to produce the second type, that is the bolt. See, so here it takes 1 hour of work on machine A and 3 hours work on machine B to produce the package of nuts. 1 hour and 3 hours for machine A, 1 hour for machine B, 3 hours to manufacture the nuts. And whereas for the bolts, machine A will take 3 hours and machine B will take 1 hour. And what is the maximum time available here? So how many packages of each should be produced? So the maximum availability of time is 12 hours. 12 hours for both A and B. Okay. Now, what is the objective function? Yeah, let us decide this as x and y. If this is x and this is y, then the objective function is z is equal to, he earns a profit of rupees 17.50 on package of nuts, 17.50x, and rupees 7 per package of bolts, 7y. So this is the objective. Therefore, the objective function is maximum z. Max z is equal to 17.5x plus 7y. Okay, now let us formulate the LPP. So subjected to the constraints, x plus 3y is greater than or equal to 2, less than or equal to 12. This is maximum time is 12. Therefore, so let us form the LPP. Subjected to the constraints, x plus 3y is less than or equal to 12. 3x plus y is less than or equal to 12. And the non-negative restrictions, x is greater than or equal to 0 and y is greater than or equal to 0. That's it. Now, therefore, the required LPP is max z is equal to, maximum z is 17.5x plus 7y subjected to constraints. What are the constraints? X plus 3y is less than or equal to 12 and 3x plus y is less than or equal to 12, and the non-negative restrictions, x is greater than or equal to 0 and y is greater than or equal to 0. This is the required LPP. That's it. Now solve this as usual. Now let us come to the first line. I will solve this. Now line 1, first line 1. Let us convert these inequalities into equalities first. X plus 3y is less than or equal to 12 can be written as x plus 3y is equal to 12. Divide by 12, x by 12 plus 3y by 12 is equal to 1. 3 4s gets cancelled. X by 12 plus y by 4 is equal to 1. Therefore, the coordinates of A is equal to 12, 0 and B is equal to 0, 4. For the second line, let us come to the second line, line 2. For the line 2, 3x plus y is equal to 12. Again divide by 12, you will get 3x by 12 plus y by 12 is equal to 1. 3 4s are x by 4 plus y by 12 is equal to 1. Therefore, the coordinates of C is 4, 0 and D is equal to 0, 2. Okay, so for the first line you are going to get the coordinates as 12 comma 0 and the point B as 0 comma 4, and the second line C is 4 comma 0 first point and the second point is 0 comma 12. Let us represent this on a graph sheet. Okay, the graph is, I will draw the graph here. I'll rub this and I will draw the graph. Now I'll draw the graph here. This is x-axis, y-axis 0 comma 0. So let us take the scale. 1 centimeter is equal to 1 unit on x and y axis. Now each centimeter is equal to 1 because we have maximum 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Here also 1, 2, 3, 4, 8, 9, 10, 11, 12. Okay. Now A, what is A? A, 12 comma 0. X is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is A, 12 comma 0. B, what is B? 0 comma 4. B 0, X is 0, Y is 4. 1, 2, 3, 4. This is B, 0 comma 4. Draw a line. This is the line. What is the equation here? So this is x plus 3y is less than or equal to 12. Less than or equal to 12 means this will goes in the downwards direction. And the second, C is equal to 4 comma 0. X is 4. 1, 2, 3, 4. This is C. 4 comma 0. And D, 0 comma 12. 0, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is D. Now, what are the points? This is for the first column. Now, let us represent for the second line. The first point C, 4 comma 0. C, this is 4 comma 0. And D, 0 comma 12. 0 comma 12. Draw a line. This passes through these 2 points. These are the points. Now, what is the line? This is 3x plus y is less than or equal to. Now, see, less than 12 means this will goes in the downward. So, this is the feasible region. What is the feasible region here? This is the feasible region. And this is the point E. If you draw the graph properly, exactly this will cut at 3 and at 3. So, you will get x as 3 and y as 3. Now, therefore, the corner points are O, 0 comma 0. Then, this is B. B, what is B? 0 comma 4. And E, 3 comma 3. And the last point is C. C is equal to 4 comma 0. These are the corner points. So, 0, B, E and C are the corner points. These are the corner points. Now, let us find out the maximum value. What is the maximum value we are going to get? I'll rub this. Now, what is the objective function? Z is equal to 17.5 x plus 7y. Now, at O, 0 comma 0, Z is equal to 0. At next B, 0 comma 4, Z is equal to 0 plus 7 into 4. This is equal to 28. Now, at E, what is E? 3 comma 3. Z is equal to 17.5 into 3 plus 7 into 3. What is this equal to? So, this is equal to 52.5 plus 21. So, this is nothing but 73.5. 73.5. Okay? Right. Next, what is the point remaining? E, at C, 4 comma 0. At 4 comma 0, Z is equal to 17.5 into 4 plus 0. What is this equal to? 17.4 into 4 plus 0. That is nothing but 17.4. This is exactly equal to 70. Now, at C, 4 comma 0, Z is equal to 17.5 into 4 plus 0. This is 17.5 into 4 is 70. Now, this is the table. Now, what is the maximum value? Here, what is the maximum value? Maximum value is, this is the maximum value. Maximum is 73.5 at 3 comma 3. So, therefore, it is maximum at 3 comma 3 and maximum value is equal to 73.5 is the maximum value. So that means when he produces 3 pockets of nuts and 3 pockets of bolts, you will get a maximum profit of 73.5 rupees. That's it. Okay. Hope you followed. Now let us come to the next problem. A diet contains at least 80 units of vitamin A and 100 units of mineral. So let us write down. This is food F1 and vitamin A. This is vitamin A and minerals. Now, so what is a dietitian contains at least 80 units of vitamin A. Availability. Availability here is 80. 80 units of vitamin A and 100 units of minerals. This is the availability. Now, food F1 cost, that is 2 foods F1 and F2 are available. F1 cost. So, what is the cost of F1? Rupees. So, therefore, the objective function is Z is equal to, let us define the decision variables. Let X and Y are the decision variables. So, the objective function is 4X, rupees 4 for food 1 and F2 is rupees 6Y. Z is equal to 4X plus 6Y. Okay. Now, one food F1 contains 3 units of vitamin A and 4 units of minerals. And second, 1 unit of food F2 contains 6 units of vitamin and 3 units of mineral. Okay, formulate this as an LP. That's all. So, now, therefore, the objective function is, what is the objective function? Minimum. Minimum of Z is equal to 4X plus 6Y. Subjected to the constraints for vitamin A, subjected to the constraints, 3X plus 6Y is greater than or equal to 80. 4X plus 3Y is greater than or equal to 100. That's it. Now, so I'll write here, subjected to the constraints. What are the constraints? 3X plus 6Y is greater than or equal to 80. 4X plus 3Y is greater than or equal to 100. And the non-negative restrictions, X is greater than or equal to 0. And Y is greater than or equal to 0. This is the required LPP. That's it. Now, I'll go to the next page. Therefore, required LPP model is minimum Z is equal to 4X plus 6Y subjected to constraints. What are the constraints? 3X plus 6Y is greater than or equal to 80 and 4X plus 3Y is greater than or equal to 100. And the non-negative restrictions, X is greater than or equal to 0 and Y is greater than or equal to 0. Now solve. To solve, convert this linear inequalities into equalities. Now line 1. What is the first line? 3X plus 6Y is equal to 80. Okay. Now divide by 80, you will get, what you will get? 3X by 80 plus 6Y by 80 is equal to 1. So this can be written as X divided by 80 by 3 plus. So if you divide this from 2, you can divide. So that is 2 3s are 2 4s are. So this is Y divided by 40 by 3 is equal to 1. So therefore, the coordinates of A is equal to 80 by 3 comma 0 and B is equal to 0 comma 40 by 3. Okay. The coordinates of A, therefore, A is equal to 80 by 3 comma 0 and B is equal to 0 comma 40 divided by. Now let us come to the line 2. What is the line 2? This is line 2. Line 2 is 4X plus 3Y is equal to 100. Divide by 100. 4X by 100 plus 3Y by 100 is equal to 1. This is 25 times cancel. And what is this equal to? You will get X by 25 plus Y divided by 100 by 3 is equal to 1. So therefore, the coordinates of C are 25 comma 0 and D is equal to 0 comma 100 by. So these are the point of contact. So these are the coordinates of the line A line 1 and line 2. Now let us draw this on a graph sheet. Let me draw the graph here. I will draw the graph here. A, I write on the points. A, 80 by 3 comma 0. B, what is B? 0 comma 40 by 3. C, 25 comma 0, and D, 0 comma 100 by 3. Let me rub this. Now let us 80 by 3. 80 by 3 can also be written as, this is 26.7. Yes, this is 26.7 comma 0. This is 0 comma 40 by 3. 40 by 3 means how much we will get? So this is 0 comma. So this can be written as 0 comma 40 by 3 means 13.4. This is D, 100 by 3, 33.33. Or you can take this as 0 comma 33.4. Okay, now let us draw on a graph sheet. X-axis, y-axis, 0. Let us consider each unit is equal to 5, 5. So the scale is 1 centimeter is equal to 5 units on x-axis and y-axis. This is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 5, 10, 15, 20, 25, 30, 40, 45. Now A, what is A? 26.7. This is 5, 10, 15, 20, 15, 20, 25, 30, 35. This is 5, 10, 15, 20, 5, 10, 15, 20, 25, 30, 35, 40, 45, like this. Now A, 26.7. 26.7 means here it is. A, that is 26.7 comma 0. This is A. And what is B? 0 comma 13.4. 0 comma 13.4. Somewhere it is B. 0 comma 13 point. Let us draw a line. These two. So what is this line? This equation, first equation is 3x plus 6y is greater than or equal to 80. 3x plus 6y is greater than or equal to 80. Greater than means it will goes in this direction, away from the origin. Next, second point. What is the second point? C, 25 comma 0. This is 25. This is 25. C, 25 comma 0. And D, 0 comma 33. 0 comma 33. This is D, 0 comma 33.4. So this will pass us through this point. What is the curve here? The curve here is 4x plus 3y. 4x plus 3y is greater than or equal to 100. So this is again greater than or equal to 100. So therefore, this is the feasible region. That is, this is an unbounded region. Feasible region. This is an unbounded. So we will get an unbounded region for this curve. Now, what are the corner points? Therefore, these are the corner points. D, corner points are D, 0 comma 33.4, and another point where it will cuts at this point and at this point. A, what is A? A is 26.7 comma 0, and at this point, this is E. Let us call it as E. What is E we are going to get? So if we observe carefully, so this is one corner point 0 comma 33.4. Another corner point is A. What is A? 25 comma that is A, 26.7 comma 0. Another point is E. So what is E here actually? This is X. Somewhere you will get the value of X very near to this, and the value of X is here and Y is here. So if you solve the equations, the values of X and Y you are going to get for this is this X is around 25 less than this is 24 comma, and the value of this is even less than 5. So around one value you will get, this is 4y. Okay. Now, so therefore this is another point. E is equal to 24 comma 4 by. These are the corner points. Now find out the maximum or the minimum value for this. Okay, so now I'll rub this. So therefore the corner points are C. C is equal to 0, 100 by 3 is the first point. Okay, another point E is equal to 24, 4 by 3 is another point, and D 80 by 3, 0. Substitute here. What is the objective function? Minimum z is equal to, what is minimum of z is equal to 4x plus 6y. Now at C 0, 100 by, at C 0, 100 by 3, what you will get? Z is equal to 4 into 0 plus 6 into 100 by 3. 3 2 gets cancelled. This is 200. One value is 200. Okay. Now at second point E, at E 24, 4 by 3. Z is equal to 4 into 24 plus 6 into 4 by 3. What is this equal to? So 24 into 4, 96 plus 3 2s gets cancelled, 4 2s are 8. So 96 plus 8 is nothing but 104. This is 104. Okay. And the last at D 80 by 3, 0. You will get Z is equal to 4 into X is 80 by 3 plus 0. So this is nothing but 80 by 3 into 4. That is equal to, cancel this. So that is 4 into 80 divided by 2. 320 divided by 3. That means this is almost equal to 3 1s are 3 6 are 18, 106 point something you are going to get. So now, okay, at the last point at D 80 by 3, 0, Z is equal to 4 into 80 by 3 plus 0. This is nothing but 320 divided by 3 is equal to 106.66. So 106.66. Now, what is the intention is to get the minimum value. What is the minimum value? Minimum value is 104. This is the minimum value. So the minimum value is 104. So therefore, minimum value is 104 at 24, 4 by 3. This is the minimum value of the function. Hope you understood. These are the problems in linear programming problem. We will continue in the next class. Thank you. Thank you very much.